In this video, we are going to go over the explanation of task 1 using the AWS console. Here, we have a rough overview of the steps we'll have to take. The first step is to provision security group. So let's head over to the AWS console now. Once you're on the AWS console, search for the service EC2, navigate and search for the tab Security Groups. Over here, you can click Create Security Group. For this task, we'll need to create two security groups, one for web service, another for the load generator. Let's start by creating a security group for the load generator. I will call it load generator security group. Make sure to also give it a description, and we can leave the VPC as the default VPC. We will now need to allow a rule to enable incoming HTTP traffic. To do that, click on Add Rule, specify the HTTP service, and for the source, allow access from anywhere. Make sure to add any additional information as specified by the write-up, like the project tag. Note that the project tag you might have may differ from the one I am typing, so make sure to double check the handout. Click on Create Security Group. Once complete, you can follow a similar process to create security group for the web service. With security group now provisioned, we can create a new load generator instance. Thanks to the primer, you should be familiar with the process of launching a new EC2 instance from the AWS console. Let's go over it again using a custom AMI. Head over to the Instance tab and click on Launch Instance. Here, give the load generator a name and additional tags that your handout or write-up may have to avoid any tagging penalties.
Please note, it's also important that you tag the resources that are associated with the instances, like the block volumes and the network interfaces. Now, moving on.
For the image, head over to the write-up and locate the load generator AMI ID. Over here, I can see that for load generator, I have to use this AMI ID. Click on Browse More AMIs, select Community AMIs, and paste the AMI ID which we just copied from the write-up. We'll have to use this AMI for this project. For the instance type, I'll head back again to the write-up and confirm the instance type that I have to use, which in this case is M5 large. I'll search for the M5 large instance. For key pair login, we will proceed without a key pair since we do not have to connect to our load generator instance. For the security group, we will select the existing security group that we just created in the previous step. We can leave everything else as default and launch the instance. Once the instance is in the running state, we can click the instance ID, copy the public IPv4 DNS, and open the DNS in a new tab. You should be able to see this screen. If you are facing errors like cannot connect to server, this means that server is still booting up and it needs more time. Wait a couple of minutes and try it again. Once you are greeted with this page, it means that the steps taken till now are correct. The next step in the process is to launch a web service instance. This will involve same steps as launching a load generator instance by using web service AMI and the security group we created specifically for the web service. Once the web service has been created, you should be able to click on it, copy the public IPv4 DNS, paste it on your browser. If everything worked correctly, we should be greeted with this page. We should be able to click on look up a random user, where you'll be greeted with a random number. Again, if you're not able to see this page, double check the security group and the AMI you have used. Now, we can proceed with our horizontal scaling test. Let's go back to our load generator homepage. Once here, click on the horizontal scaling test. We'll have to add the DNS of the web service that we just created. For that, we can head back to our instance page. For the web service, we'll copy the public IPv4 DNS and paste it. Then click submit. You should be able to see a test being launched, and when you click on this test, you should be able to see the logs of the current test that you're running. After some time, if you look at the log, it becomes clear that one web server instance will not be enough to reach the target RPS of 50. We will therefore need to launch and register more web server instances, which brings us to our last step. Follow the same steps as before to create a new web server instance, and once that is complete, copy down the public IPv4 DNS of the new web service instance. Over here, I have created a new web service instance named web service 2. I copy the public IPv4 DNS and head back to my load generator. I'll click on add instance to the horizontal scaling test. Then paste the DNS we just copied from the web service on new web service that we created, and we'll submit it. After some time, you should see the new instance popping up in our log to verify everything went correctly. We should also see the RPS increase from 9 to 22. With this, you should now be ready to programmatically simulate what we've done using the AWS SDKs, and thus be able to complete task 1 to reach target RPS of 50 within 30 minutes. Thank you.